Hello students, welcome back to my channel. Myself Dr.Suresh Biradar. I am teaching engineering mathematics. In this video, we are going to discuss the Cauchy theorem. So what is Cauchy theorem and what is the statement of Cauchy's theorem and how to prove this Cauchy's theorem. So it is very simple one, students. Okay. Look at here, what is the statement of the theorem is, if fz is analytic at all points inside and on a simple closed curve C. Look at the meaning of simple closed curve. Okay. Then the integration of f of z dz over the curve C is equal to 0. Okay. So let us consider a curve, okay, which is a what? Closed one. Okay. Okay. It is a closed curve. Okay, you people already aware of analytic. What is the meaning of analytic? Analytic means there exists a derivative. For example, if I consider a point z is in this point, okay. If I want to say that the function is analytic at this point, okay. So there exists a derivative. Derivative means you people already aware that there exists a tangent at this point. Also, the neighborhood of this point here, 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 and here. So then we say that it is a analytic. Okay, fine. So now fz is analytic at all points in this curve. Okay, so it is analytic at all points, and the curve is closed. Then what will happen? Integration of f of z over this curve should be equal to 0. Okay, let us prove this one. Okay, let us take here let. Let's consider let. Here I am going to take fz is equal to u plus iv, and also you people already aware that z is equal to, I am going to take in terms of Cartesian form. If z is equal to x plus iy, then what is dz? Dz is equal to dx plus idy. So this is obtained by one or more independent variable or total derivative rule. It is obtained by using total derivative rule. Okay, now let us take this one. Okay, then what is integration of f of z dz is equal to integration of, I am going to take f of z is equal to, which is u plus iv. Okay. And what is dz value? Dz value I am going to take it as a what? Dx plus idy. So I want to prove this. This is equal to what? 0 over this curve C. Okay, which is equal to, can multiply first u into dx, that is u dx plus u into idy plus I u dy plus I v into dx plus into plus plus. Okay. I into I is I square. Okay, I square is v dy. Okay. Further integration of, take, okay, I square is a what? You people already aware. I square is equal to minus 1. Okay, so it is purely real. I will take first u dx. This is minus v dy plus, in these two terms I will take I common. You will get, first I am writing v dx plus u dy. So look at, so integration of a sum is sum of integration. Okay. So which is equal to integration of u dx minus u dy plus I times of v dx plus u dy. So this is over a curve C. U dx minus v dy plus I into u dx plus u dy. Okay, I will write in the next page. Just look at integration of f of z dz over the curve C is equal to integration of, this is u dx minus v dy plus I times of v dx plus u dy over the curve C. Okay, students, what is the next one? Next one is I am using Green's theorem here. What I am using? I am using Green's theorem. So what is Green's theorem? How to use this? Okay, look at, we'll write here Green's theorem statement. What is Green's theorem statement, students? Okay, so Green's theorem we are going to define in terms of a, or in a plane. Green's theorem in a plane, we are defining in a plane. Okay, so what is that? If m of x comma y and n of x comma y are real valued functions, and having continuous first order partial derivatives. So what does it mean? There exists a what I am writing here. There exists a what, some like dou n by dou x, okay, dou n by dou x, dou m by dou y, like that, okay, etc. In the region R, in some region, in region R, okay, bounded by the curve C. This is very important. Bounded by the curve C. So Green's theorem ಏನು ಹೇಳುತ್ತಂದ್ರೆ ಎರಡು ರಿಯಲ್ ವ್ಯಾಲ್ಯೂಡ್ ಫಂಕ್ಷನ್ಸ್ ಇದಾವೆ, ಅವು ಕಂಟಿನ್ಯೂಸ್ ಇದಾವೆ, ಓಕೆ, ಪಾರ್ಷಿಯಲ್ ಡೆರಿವೇಟಿವ್ ಎಕ್ಸಿಸ್ಟ್ ಆಯಿತು ಅಂದ್ರೆ ಸಮ್ ರೀಸನ್ ಅಲ್ಲಿ, ಅದು ಬೌಂಡೆಡ್ ಬೈ ಸಮ್ ಕರ್ವ್ ಸಿ ಇತ್ತಂದ್ರೆ, ವಾಟ್ ಇಸ್ ಗ್ರೀನ್ಸ್ ಥಿಯರಮ್? ಲುಕ್ ಅಟ್ ಹಿಯರ್ ಐ ಆಮ್ ರೈಟಿಂಗ್, ದಿಸ್ ಈಸ್ m dx plus n dy is equal to, it will become a what? Double integration. This is over a curve is equal to, in terms of a region, that is dou n by dou x minus dou m by dou y into dx dy. So this will become a what? The integration. Okay, look at here. Single integration over a curve C is equal to double integration of dou n by dou x minus dou m by dou y into dx dy. So I need to apply this theorem for these two. Okay, look at here. So here this will become a m. Okay, this will become a n. N is equal to what? Minus b. Similarly here this is a m, this is n. Okay, so let us apply this one and observe what will happen. Very easy one, student. ಪ್ರತಿಯೊಬ್ಬರಿಗೆ ಅರ್ಥ ಆಗುತ್ತೆ, which is equal to ಏನಾಗುತ್ತೆ ಇದು ಡಬಲ್ ಇಂಟಿಗ್ರೇಷನ್. ಫಸ್ಟ್ ಯು ಕ್ಯಾನ್ ರೈಟ್ ಡಬಲ್ ಇಂಟಿಗ್ರೇಷನ್ ಓವರ್ ಎ ರೀಸನ್ ಆರ್, ಏನಾಗುತ್ತೆ ಡೋ ಎನ್ ಬೈ ಡೋ ಎಕ್ಸ್, ಡೋ ಎನ್, ಎನ್ ಮೀನ್ಸ್ ಹಿಯರ್ minus v, so it will become minus dou v by dou x minus dou by dou y of m, m means u. Fine. Into dx dy plus I times of, again double integration over a region R, m means this is dou n, n means u, dou u by dou x minus dou v by dou y into dx. Okay, further look at, after applying a Green's theorem, we know that fz is analytic. Fz is analytic means, you people already aware that fz is analytic means we know that it satisfies CR equations, Cauchy-Riemann equations. Okay, let us apply Cauchy-Riemann equations for these two integrals, double integrals. Okay, so since you can write, since fz is analytic means it satisfies CR equations. So what are the CR equations? Okay. So let us first copy this, then can go for that. F of z into dz for the curve C. For CR equations, dou u by dou x is equal to dou v by dou y and dou v by dou x equal to minus dou u by dou y. Okay. Okay. Let us use this for, so integration of f of z into dz, right, as it is. It's a double integration over the region R. You can write minus dou v by dou x as it is. What is dou u by dou y? Dou u by dou y is, you can bring this minus sign to left side. So it will become minus minus plus dou v by dou x into dx dy. Similarly, plus I times of double integration over the region R. You can write dou u by dou x as it is. What is dou v by dou y? What is dou v by dou y is same as again dou u by into dx. Look at, so minus and plus get cancelled. Integration of 0 is 0. Here also this is I times of 0. So this total is 0. So that's it. So integration over a closed curve C, f of z dz is equal to 0. Okay, we shall also observe some consequences of a Cauchy's theorem. What are the consequences of Cauchy's theorem? So let us write consequences of Cauchy's. So there are three consequences. Just you can concentrate carefully. What are the consequences is, I'm not going to write anything, just I'm going to explain here. Okay, so you can consider, you can observe there are 2 points in a plane, call it as P and Q. Okay, you can join these 2 points by using 2 curves. I'm writing one from here and one from here. So how do you traverse? So I'm going to traverse. Once again I'm going to take 2 points on this curve. Let us A and. So how to traverse from P to Q here? So I'm going to travel. As you know that if you want to apply a Cauchy's theorem, it should be a what, closed one. Okay, I'm going to travel from P to PAQ plus QBP curve. So now observe. So what is the consequence? First consequence is you can travel from P to Q or Q to P on any direction or any ways, then it is independent, means independent of path joining P and Q. Means you can traverse from any way then the value of integral is equal. Okay. So for that you can call this is some curve C1, this is curve C2. So what will happen? So PAQ plus QBP makes a what? A closed curve. Then look at the direction. This is PAQ. This will become a minus PQ reverse order. Okay. So for this is curve C1, this is curve C means both are equal like this. So integration over a curve C1 f of z dz is equal to integration of f of z dz over a curve C2. Means both curves are equal. So let me go for second consequence. Second consequence means I have one curve. Okay, there is one more curve inside of this. Then what will happen? So how to apply Cauchy's theorem? Cauchy's theorem means you must know that it should be simple closed curve. Here there is no closed because one contain in the another. So that's what we are using one cross cut here. Okay. Then after using a cross cut, just look at here. I'm going to call it as some. This is some point. This point is P. I will take this point is some Q. Okay. This is some S T. This is some R. The point I am taking. Okay. Now how to make this is connected? Okay. Look at. I am going from P T S P. P T S P means this is over. I'm going inside PQ plus once again Q. This is R. I have taken Q R Q. Q R Q plus QP. Now it will become a connected. So if it is connected means what will happen? This is called curve C. Inside curve is called as what? Called as C2. This is C1. Therefore, integration of f of z dz over curve C1 is equal to integration of f of z dz over curve C2. This is the second consequence. Let me go for third consequence. Third consequence is, look at, I have a one curve here. It containing so many curves. So again, what I'm doing is I'm using cross cuts here. This curve is a C. Okay. You call it as this is some C1, C2, C3, C4. What will happen? Since we know that Fz is analytic inside and on simple closed curve C and between the annular region. So what will happen? Integration of f of z dz over curve C is equal to f of z dz over curve C1 plus f of z dz over curve C2 plus if you have number of curves, call it as some Cn. Okay, so dash 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 f of z dz over curve Cn. So that's it. These are the consequences of Cauchy's theorem. Thank you so much for watching. We'll meet in the next video.